Today, we will show how Industry 4 is transforming agriculture, energy, and manufacturing to meet society's need for food, power, and goods. We start with the Midwest's shift to smart, data-driven agriculture, then explore AI-powered decentralized energy grid, and finish with how dark factories and digital twins are redefining modern manufacturing. Agriculture has reached a critical inflection. As we move toward a global population of 10 billion, the industry is shifting from broad acre farming to precise plant level management. Economically, US agriculture contributes $1.5 trillion to GDP, but the 2026 forecast is sobering. Net farm income is projected at $153 billion, a 2.6% real decline. This financial pressure is accelerating consolidation, with 15,000 farms expected to disappear this year, while also driving the adoption of equipment as a service and agrivoltaics. With the average producer now 58 years old, this aging workforce is rapidly adopting autonomous systems. Technologies like John Deere's See and Spray are already reducing chemical usage by nearly two-thirds. Ultimately, our analysis show that 2026 success goes beyond yield. The new value proposition centers on digital traceability and the sustainable management of biological data for both environmental and economic survival.
The energy sector is experiencing a large amount of innovation as Industry 4.0 continues to drive technology. This is mainly done out of necessity as countries around the world are experiencing increased power demands. Countries are generating and receiving power and transmitting it across domestic and international borders. With such demands, they're spending trillions of dollars. Globally, the cost of energy production equals about 8 to 10% of the global domestic product and has reached approximately 176 trillion US dollars worldwide. New technologies are leading to things like decentralized power, where homes generate power with solar panels, and also the creation of renewable fuels like green hydrogen and methane that are generated using solar and wind power. The workforce faces changes as well, as they are having to increase their own skill sets or learn new ones to keep in pace with the new technologies. However, even with the increased use of automation and intelligent machines, there are indications of growth in the workforce, as the number of jobs in 2025 rose by 1.3% to about 76 million workers worldwide.
Manufacturing remains a core pillar of the global economy. It generates more than 16 trillion annual value added and accounts for nearly 70% of global merchandise trade. In the United States alone, it contributes about 2.7 trillion to GDP and supports over 12 million jobs. However, production capacity is highly concentrated. China and the United States account for near roughly 45% of global manufacturing output, and that concentration carries strategic implications. At the same time, the sector is undergoing rapid transformation. Record levels of industrial robot deployment and more than 150 daily integrated lighthouse factories worldwide demonstrate that competitiveness is shifting away from low labor costs and towards automation, digital integration, and capital intensity. Manufacturing is not declining. It is being reconfigured under technological acceleration and geopolitical pressure. Lastly, the transformation across agriculture, energy, and manufacturing is structural, not temporary. Industry 4.0 is redefining how these sectors produce, scale, and compete, meaning rising global demand will require digital integration, sustained capital investment, and workforce adaptation. Firms and regions that align technology, economics, and human capital will capture productivity gains and long-term resilience, while those that fail to adapt risk falling behind in an increasingly digital industrial system. Thank you.